Welcome to another math problem of the week. N, K are positive integers. The expression equals to 2 to the power of K. Let's talk about it. This question is come from Japan Junior Math Olympiad 2014. Suppose Nk are positive integer. How many order pairs Nk such that n to the power n plus n plus 2 over n plus 1 square equals to 2 to the power of k. And the options are A, 1, B, 2, C, 3, and D, 4. This question is very challenging. Please have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
We will have a few steps to solve this question. The first step is I want to show that n is an odd number. So I make a first claim, n is an odd number. Suppose not, then it means that n is an even number and n plus 1 is an odd number. So I will let p be an odd prime factor of n plus 1. And hence, n to the power of n plus 2 must be congruent to 0 mod p square, because that is n plus 1 square. Since p is an odd prime factor of n plus 1, I'll let n plus 1 equals to p times t. So n is equal to pt minus 1. Next, we are going to use the binomial theorem to show that this is not possible and use a contradiction. Now, n to the power of n plus 2 will be equals to pt minus 1 to the power of n plus pt minus 1 plus 2. Using binomial theorem, when we expand this pt minus 1 to the power of n, we will ignore all the terms where pt power at least 2. So what we left is only n choose 1 pt negative 1 to the power of n minus 1. The last term negative 1 to the power of n. And what we have here, just copy mod p square. Since we are assuming that n plus 1 is an odd number, so n is an even number, so negative 1 to the power of n will be a positive value. And these two will be cancelled off. These two will be cancelled off. Negative 1 to the power of n minus 1 will be of value negative 1. So this will be congruent to n times p times t, where n itself is equals to pt minus 1 times pt and negative 1 plus pt plus 2 mod p square. Now when you expand this, there is pt square. Then we can just ignore it because mod p square, and there is pt plus 2. There will be 2pt plus 2 mod p square. By using this assumption, n to the power of n plus 2 must be congruent to 0 mod p square. This has to be congruent to 0. And this means that 2pt plus 2 must be equal to a multiple of p square, say a p square. So 2 will equals to p a p minus 2t. And this is a contradiction because both are integers and this is an odd number. The product cannot be equal to 2. So means that this is not going to be happen, and it means that the assumption is not correct. And therefore, our claim here is correct. So this is the first step, and what we have so far is n has to be an odd number. There are many ways to show that n is an odd number, but I'm going to use a similar idea, that is binomial theorem, for the next argument. If you enjoyed this video, Please like, comment and subscribe. Now we have shown that n is an odd number. I'll let n to be 2 to the power of m times d minus 1, where d is an odd number. And also I'll let b to be n plus 1, that is 2m times d. So now what we have is 2 to the power of k is equal to n power n plus n plus 2 over m plus 1 square. It can be written as n, that is b minus 1 power b minus 1 plus b minus 1 plus 2, that is b plus 1 over b square. So we'll consider this term now. So b minus 1 to the power of b minus 1 plus b plus 1. Note that b minus 1 itself is an odd number. Using binomial theorem, then we see that this will be equal to b to the power of b minus 1 minus b minus 1 choose 1 and b to the power of b minus 2 all the way to b minus choose 3, b power 3 and minus b minus 1 choose 2, b square plus b minus 1 times b and minus 1. That is an expansion of b minus 1 to the power of b minus 1. And after that, don't forget to plus b plus 1. So I just copy down plus b plus 1. You don't have to worry too much about all this term. We'll just copy down and we'll focus on here. First of all, what we have here is negative 1 and plus 1, they will cancel off. Negative b and plus b, they will cancel off. And I left with b square here. And negative b minus 1 choose to b square. So it will be plus b square 1 minus b minus 1 b minus 2 over 2. After we do some calculation here, this is negative b minus 3 over 2 and b square. Now note that 2 to the power of k is equals to this expression. And therefore, from here, we know that 2 to the power of k can be written as every term here divided by b square. So this will be b minus 3 minus b minus 1 choose 1, b minus 3, all the way to b minus 1 choose 3, b. And for this, it is just b over 2, b minus 3. Now note that b itself has a factor of 2 to the power of m. So each of the term here contain a factor of 2 to the power of m. But for this, it does not contain the factor of 2 to the power of m, but it contains a factor of 2 to the power of n minus 1. And from here, it means that k must be less or equal to m minus 1. Let me erase here to save some space. Now with this result, then we know that 2 to the power of k will be less than or equal to b over 2, which is certainly less than b. And therefore now, b minus 1 to the power of b minus 1 plus b plus 1 over b square will be strictly less than b. And therefore, b minus 1 to the power of b minus 1 plus b plus 1 will be strictly less than b power 3. Then we know that with this inequality, b cannot be a very big number. In fact, it will just follow that b must be less than 5. b is less than 5 and b is an even number, so it can be 4 or 2. And we can check that b equals to 4, n will equal to 3, and it will produce k equals to 1. b equals to 2, n will equal to 1, it will produce k equals to 0. And we already know that both n and k are positive integer, so we cannot accept the value k equals to 0. And that's right, in this case, we have only one solution. This question is very challenging And when we do that, we may overlook and get the correct answer by using wrong argument. I'm happy to receive some responses. And for now, let's look at the responses and solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.